When we talk about outdoor air has such a huge impact to a HVAC system, whether it's on the roof or whether it's a terminal unit. And especially if you're going to increase the amount of outdoor air, that impact can be quite dramatic. So we use energy recovery ventilation systems in order to temper the outdoor air that's coming in with the energy that we would be throwing out from the exhaust air. So let's take a look at energy recovery and what that means, because there are various types of energy recovery equipment and they're not all the same. So with Renew Air energy recovery ventilation, we have something called balanced ventilation. And what balanced ventilation means is that when we take 1 cubic foot of stale indoor air and throw it out, we bring 1 cubic foot of clean, fresh outdoor air and bring it in. So we have two fans that are operating in concert with each other, one exhausting the air and one bringing in the outdoor air. Now, that energy transfer occurs through a core that looks like a cardboard box, as you see depicted on the screen there. What's interesting is that you bring in, you take the exhaust air from the room, put it across one side of that energy recovery core, where we're transferring both the sensible and the latent energy. Now, this is what becomes interesting. There are products that are called HRVs, which are heat recovery ventilators, that only transfer sensible energy. What we're talking about is energy recovery ventilators, which is a total energy, and you transfer both the sensible energy and the latent energy. So that is the cooling or the heating that occurs, simultaneously transferring moisture. Now, obviously, in the wintertime, we want to transfer the moisture from the exhaust air back to the outdoor air that's coming in. And then in the summertime, we want to take the moisture that's coming in from the outdoor air and dump it into the exhaust air and throw that out. So that tempering occurs in regardless what season that you may be in. Now, because we're using an enthalpic core, there's an actual physical separation of the airstreams, meaning that the airstreams do not touch each other. So that assures next to zero cross-contamination, or less than 0.1% cross-contamination. And depending on how you set the pressures, depending on how the consulting engineer and the contractor set the parameters, we're able to assure zero cross-contamination. So these systems would be great not only for new buildings, but also for retrofit applications. And what's critical is when we say low to zero exhaust air transfer ratio, and not all energy recovery systems, whether they're energy wheels or whether they're HRVs, are equal to these type of static plate core energy recovery equipment, because some of them can transfer and cross-contaminate as much as 12 to 18%. So using the right type of technology, and more specifically, making sure that you're transferring both latent and sensible energy becomes paramount than just transferring only sensible energy.
Nick, thanks for introducing the concept of energy recovery ventilation. This is something that I had numerous conversations with principals and teachers and facilities folks in schools, because not all schools were familiar with the concept of energy recovery ventilation. They're used to just bringing in the air directly from the outside through the unit ventilator and introducing it into their classroom. And the example that I often gave to help them understand this concept a little more is on the extreme example. So it's a cold winter day in Vermont, it's 0 degrees outside. Your heating coil has to heat that air from 0 degrees all the way up to probably 68 degrees before it's introduced into the building. And that's the way that you're ventilating your space. And think of the energy, your boiler energy that it's taking to heat that air from 0 to 68. The reason that we want to encourage the use of energy recovery ventilators is that we're taking that air that we've already spent the money to heat, and we're using that to temper that 0 degree air. So instead of heating that air from 0 to 68, now we're able, through an energy recovery ventilator, to temper that air, and we only have to heat it from, say, 40 or 50 degrees all the way up to 68 degrees. And again, that's going to depend on the air conditions and the effectiveness, but I just wanted to share that example of how I'm often using the discussion around ERVs to talk to schools and the benefits that they're going to gain in terms of operational costs, because we all know that budgets and operational costs are paramount for schools these days.